Welcome. Today, we're diving into the technical world of modern fire apparatus and water delivery. We'll explore truck classifications, incident operations, and the mechanics behind centrifugal and priming pump hydraulics. Plus, we'll look closely at high-pressure hose reel technology. This is all about understanding the tools that keep firefighters effective and safe. Let's get started. Today, we're diving into apparatus tech. That means looking closely at the standard setups and capabilities of emergency vehicles. We'll focus on how these vehicles are classified, all under the guidelines set by the NFPA standards. This module gives us a solid foundation for understanding the different types of apparatus and what each one is designed to do. Let's get started with the basics of apparatus classifications. Let's take a look at the main classifications of firefighting apparatus. First, we have wildland and light attack units. These are types 3 through 7. They're built for off-road use and quick, mobile suppression, often equipped with pump and roll systems to fight fires on the move. Then there are structural capabilities, types 1 and 2, designed for tackling structural fires. These rigs need powerful pumps with high flow rates and a large set of ground ladders to handle complex building emergencies. Let's break down the key specs for a Type 1 fire engine. It needs to carry at least 1,200 feet of 2.5-inch hose, plus 500 feet of 1.5-inch attack lines. The crew size is 4 fully equipped firefighters, enough hands to handle the toughest situations. Water capacity, a minimum of 300 gallons on board. And the pump, it's rated to deliver at least 1,000 gallons per minute. These standards ensure the engine is ready for serious firefighting right out of the gate. Let's talk about the Type 2 urban and suburban pumper. This rig runs smoothly with just 3 crew members, making it efficient on personnel. It carries 300 gallons of water on board, enough to tackle many common emergencies. With a pump rate of at least 500 gallons per minute, it delivers solid firefighting power. Built for suburban neighborhoods with medium density, it strikes a balance, strong enough for structure fires, yet compact and nimble for tight streets. Versatility and maneuverability are its key strengths. Let's talk about the key features of Type 3 and 4 engines used in firefighting. These rigs carry over 500 gallons of water, which is crucial when fighting fires in remote areas. They're designed to pump water while on the move. That's the pump and roll capability. Pump rates vary. Type 3 delivers at least 150 gallons per minute, Type 4 at 50. And they're built tough, with high ground clearance and heavy-duty 4-wheel drive for off-road challenges. Let's look at 3 types of light attack units designed for quick response in wildland firefighting. First, the Type 7 is extremely lightweight, with a maximum weight of 14,000 pounds. It carries just 50 gallons of water and a 10-gallon per minute pump, perfect for rapid, minimalist interventions. Next, the Type 6 steps up with a light pickup chassis, holding 150 gallons and offering great maneuverability in brush. Finally, the Type 5 is the heaviest of the 3, with a 26,000-pound chassis, a 400-gallon tank, and a 50 GPM pump for more substantial, fast-acting fire suppression. The Quints fire apparatus is a true multitasker. It combines 5 essential functions into one vehicle, making it incredibly versatile on the fireground. It carries a large water tank, at least 300 gallons, and includes a powerful, permanently mounted pump that delivers a minimum of 1,000 gallons per minute. Along with hose and ladder capabilities, it's designed to handle both engine and ladder duties seamlessly. This convergence means faster, more efficient responses when every second counts. Let's talk about mobile water supply units, the workhorses of water transport in areas without hydrants. These units, often called tenders or tankers, carry between 1,000 and 4,000 gallons of water. Their tactical job is to feed static portable dump tanks, using multi-directional valves that allow for fast, high-volume dumping. They're essential for supporting operations in rural or remote locations, where reliable water sources just aren't available. Let's talk about aerial and special apparatus, the heavy hitters in rescue operations. These vehicles are built for tough jobs like vehicle extrication, trench rescues, structural collapse, and high-angle technical rescues. They're also equipped for hazardous materials containment. Heavy rescue units come with rugged buckets and tactical water monitors, creating safe platforms for high-altitude work. Then we have aerial ladders, hydraulic, heavy-duty, and extending well over 75 feet. They're designed for high-elevation extraction and powerful water delivery when it counts most. Now, let's dive into apparatus technology, the tools and techniques that shape how we deploy water, manage drafting, and move tactically on the fireground. This module focuses on the practical side of firefighting operations, where every decision impacts effectiveness and safety. We'll explore how these elements come together to support firefighters in the heat of action. Understanding this helps us work smarter, faster, and more coordinated when it matters most. Let's dive into some core suppression operations that keep firefighting effective and efficient. First, frictional compensation. That's adjusting engine pressure to overcome hose friction, based on diameter and length. Then, water shuttle tactics, using mobile tenders and drop tanks to maintain supply in rural areas where hydrants are scarce. Exposure protection comes next, deploying wide fog and high-flow master streams to shield nearby commercial buildings. Finally, initial attack deployment, sending in fast attack lines for quick interior knockdown and cooling. Each tactic plays a crucial role in controlling the fire. Let's talk about drafting and how we source water from static supplies. This method uses rigid hard suction lines and strainers to pull water. There's a theoretical lift limit of just under 34 feet, but in practice, fire crews usually work within 10 to 15 feet. To get water flowing, air has to be removed from the suction lines, creating a pressure drop. Drafting is crucial when there are no hydrants nearby. It lets us tap into lakes, pools, or reservoirs. It all comes down to using atmospheric pressure to move the water. Let's talk about tactical pump and roll operations. This technique keeps water pressure steady and strong, no matter how fast the vehicle is moving. To pull this off, we rely on extra engine-driven pumps or advanced power takeoff systems. The key is that the fire pump runs completely independent of vehicle speed. This method is especially useful in brush clearing and perimeter control, where firefighters attack the fire line with handlines while the apparatus moves alongside. It's a dynamic way to suppress moving wildland fires effectively. Let's dive into the engineering behind some of the toughest liquid displacement systems out there. We're talking about apparatus tech, the kind that powers fire pumps and hydraulics. These systems need to be incredibly reliable, built to perform under pressure, and designed with precision. In this module, we'll explore the core principles that make these machines work so well, even in the most demanding situations. Let's talk about onboard fire pump designs, the heart of many firefighting vehicles. These pumps can be powered by the vehicle's transmission PTO or by independent diesel motors. They're often used in pump and roll setups, where mobility and water flow go hand in hand. We've got auxiliary and PTO pumps that are self-priming, essential for clearing air from the pump housing during drafting. Then there's the main operational pump, usually centrifugal, spinning an impeller to deliver a steady, high-volume flow under pressure. Let's talk about how centrifugal fire pumps work. They need external priming. They can't pump air, only water. Inside, a brass impeller spins fast, pulling water into its center. The impeller vanes then fling the water outward, creating pressure inside the volute housing. It's a clever way to convert kinetic energy into powerful water flow. All this happens with simple mechanical valves, allowing the pump to move huge volumes of water without taking up much space. Let's talk about positive displacement pumps. They're key when we need to switch to drafting mode at static water sources. Unlike main centrifugal pumps, which can't create a vacuum if they're filled with air, these small electric-driven rotary primers clear the air out. That lets water flow into the main pump. They're also great for tasks like injecting high-viscosity foam or purging air. These pumps move a fixed volume of water with each rotation, pushing it out mechanically. Rotary gear and vane types are common examples we rely on. Let's take a closer look at the flow capacities required by NFPA standards for fire apparatus. This slide gives us a clear comparison of the minimum gallons per minute, or GPM, that different vehicles must deliver. Understanding these flow rates is crucial because they directly impact how effectively firefighters can control and extinguish fires. It's all about making sure the equipment meets strict performance benchmarks, so safety and efficiency go hand in hand. Now, let's focus on standard agent allocation, a key part of how we organize resources efficiently. This approach ensures that each agent is assigned tasks based on clear criteria, balancing workload and expertise. By doing this, we keep operations smooth and responsive, avoiding bottlenecks. It's a straightforward system, but it makes a big difference in how well the team performs day to day. In this module, we're diving into apparatus technology, focusing on quick-attack booster systems and high-pressure water mist technologies. These tools are essential for rapid response and effective fire suppression. We'll also explore hose reels and deployment strategies, looking at how they work together to get water where it's needed fast and efficiently. Let's break down the tech that helps firefighters stay ahead in critical moments. Let's talk about booster hose reels, sometimes called quick-attack lines. These are designed primarily for smoldering rubbish and controlling wildland perimeters. They usually flow at a lower rate, between 15 and 30 gallons per minute. The tubing is built with a rigid or semi-rigid rubber jacket, so it won't collapse during use. What's key is that these reels stay under pressure all the time, ready to go instantly. That means no delays when speed is critical for perimeter control. Let's talk about high-pressure and ultra-high-pressure hose reels. These reels need heavy-duty casings to handle the intense pressure. They're designed to conserve up to 90% of water during interior fire attacks. That's a huge efficiency boost. The ultra-high-pressure systems operate above 1,000 psi, breaking water into tiny droplets. This atomization helps absorb heat quickly, leading to faster knockdown of fires. It's all about advanced thermodynamic misting, using science to fight fire smarter and faster. Let's break down the key fire hose specifications that guide how firefighters choose their equipment. We start with the booster line's small diameter, low flow, perfect for quick attacks on dumpsters or small brush fires. Next, the attack line, a bit larger, with enough flow to handle interior structural fires. Then, the tactical line, bigger still, designed for large volume attacks or backup support. Finally, the large diameter hose, or LDH supply. This one moves massive amounts of water from hydrants to engines, keeping everything flowing. Each hose has its role. We've reached the final slide in our training program. If you have any questions or need technical support, you can reach out directly to our lead instructor via the email provided. Thanks for joining us in this fire apparatus and pump operations training. We hope you found it valuable and feel more confident in your skills moving forward. Remember, support is just an email away. Before we wrap up, here are the sources for the images used throughout this presentation. They come from a variety of places, from technical diagrams to real-world photos. These visuals helped us explore the inner workings and applications of pumps and fire trucks in detail. Giving credit to these sources is important, as they provide the foundation for the clear and accurate visuals that supported our discussion today. That wraps up our presentation. Before we go, here are the sources for the images we used, giving credit where it's due. It's important to acknowledge the work and resources that support our ideas. Thanks for joining me on this journey. I hope you found it insightful and inspiring. This video was created with SlideSpeak. Visit SlideSpeak to turn your presentations into engaging AI-narrated videos.